All right, let's talk about something every AI developer runs into. You've spent weeks, maybe months, building the perfect AI model on your computer. It's smart, it's powerful, but it's stuck. How do you actually get it out into the real world, where it can start doing what you built it to do? Well, today we're going to map out that exact journey, from the safety of the lab into the wild.
So you've done it. You put in the hours, you wrangled the data, and you've trained a brilliant AI model. That's a huge achievement. But now what? This is that critical moment, that leap from being a cool science project to becoming a tool that provides real, actual value. And that's exactly the journey we're going to unpack together.
Here's the roadmap for today. We're going to start with the big shift from training to inference. Then we'll tackle the key forks in the road: how your model predicts, where it's going to live, and what to do about the cloud. After that, we'll get into managing its lifecycle and wrap up with the thing that powers it all, the unending journey of data.
All right, first things first. You got to understand that an AI model really lives in two completely different worlds. There's the world where it's built, and then there's the world where it works.
The bridge that connects those two worlds is this big word you hear all the time: operationalization. And listen, this isn't just a fancy term for hitting deploy. It's the entire process of taking your trained model and embedding it in a real-world environment so it can finally start generating some actual, tangible value.
Now, it's super important to get just how different these two phases are. Training is the heavyweight champion. It's a beast. It chews through massive data sets and often needs seriously powerful hardware, like those expensive GPUs. But inference, that's when your model is actually live and making predictions on new data. That's a whole different ballgame. The needs are different. You might need more efficient, nimble infrastructure, and you absolutely have to be measuring its performance, like all the time.
Okay, this brings us to our very first major decision point on this journey. Once your model is ready for the real world, you have to decide how it's actually going to make its predictions. And this isn't just some minor technical detail. It's a core strategic choice that affects everything else.
And the question you have to ask yourself is pretty simple. Does my app need an answer right this second, or can the predictions happen on a set schedule? Your answer to this one question will point you down one of three very different paths.
So depending on your answer, you'll end up with one of these. If you're just generating, say, a weekly sales forecast report, then batch prediction is your friend. You run big groups of predictions on a schedule, no rush. But if you're trying to detect credit card fraud as it happens, you need an answer in milliseconds. That's real-time prediction. And then there's this third option, stream learning, which is also super fast, but it's often used to kick off other processes in the background as new data flows in, kind of like a series of dominoes. Okay, so you know how your model will predict. The next big question is, where is it going to live? You've got to find the right home for your AI, and where you put it has huge implications.
Generally speaking, you've got three main neighborhoods to choose from. You can host it on your own company's servers, which we call on-premise. You can run it directly on a piece of hardware out in the world, like a camera or a phone. That's an edge device. Or you can use what everyone's talking about, the cloud. Let's dig into the first two.
Choosing to go on-premise is like building a fortress for your AI. You have total control, total security. It's living on your own hardware, behind your own firewalls. This is the go-to choice for industries with heavy regulations like finance or healthcare, or when your model needs to be super close to your other internal data and systems.
The edge device, on the other hand, is like a scout. The AI isn't in a central fortress, it's out in the world, running directly on a phone, a smart camera, or a factory sensor. This is absolutely essential when you need lightning-fast responses or when the device might not have a reliable internet connection. Think about your phone unlocking with your face. That happens right there on the device. And that brings us to the third option, which is often the most flexible and powerful of them all. Let's do a deeper dive into the cloud. Because using the cloud isn't just about picking a location, it's about adopting a whole strategy. So, what is Cloud ML, really? Well, put simply, it just means you're using someone else's computers, a third-party provider like Amazon, Google, or Microsoft, for any part of your machine learning workflow, from building the model to running it 24/7. Now, here's the most important thing to understand about the cloud. It is not an all-or-nothing decision. You can use it strategically. For example, maybe you just rent their super powerful GPUs to do the heavy lifting of training your model, but then you deploy the finished model back in your own on-premise fortress. Or you could do the reverse. You could train the model on your own machines to keep your data private, and then upload it to the cloud just to take advantage of its incredible ability to scale up and serve millions of users.
But hold on. Before you jump headfirst into the cloud, you've got to ask some really critical questions. First, where is your data right now? Because moving petabytes of data into the cloud is not a trivial thing. It can be slow and expensive. Second, is it actually cheaper? You have to run the numbers for your specific case. And third, and this is a big one, can you even legally or securely put your data and model in a public cloud? For some companies, the answer is just no.
So let's imagine you've made all these decisions and your model is now live. Woohoo! But here's the reality check. Your work is not done. In fact, it's just beginning. This is absolutely not a set it and forget it game.
And that's where this whole discipline of ML ops comes in. You can think of it as the set of rules and tools you need to manage your model's entire life, from birth to retirement. The whole point of ML ops is to make sure your model keeps working well as the world inevitably changes around it.
The easiest way to think about ML ops is to break it into two halves. On one side, you have what looks a lot like traditional software engineering, the DevOps for ML part. That's the plumbing. Versioning your models, deploying them reliably, that kind of thing. But the other half, model-specific ops, is unique to AI. This is where you're monitoring the model's health, watching for signs that its performance is degrading, what we call model drift, and making sure you have a perfect record of where all your data came from.
And that idea of data provenance leads us right into our final and honestly our most important topic. We've talked a lot about the model's journey, but that journey is completely 100% dependent on the unending journey of its data.
I want you to let this statement sink in for a second. Managing your data's life cycle, how you collect it, clean it, store it, secure it, is every bit as critical as managing the AI model itself. Why? Because your model is just a mirror reflecting the data you showed it. If the data's bad, the model will be bad. Period.
So, as you plan your entire AI project, you need a data strategy that can answer these questions. How are you going to handle both the data you train with and the new data that comes in every day? How will you know when the real-world data starts to look different from what the model expects? How do you guarantee it's secure, private, and fair? You see, a great AI strategy is really just a great data strategy in disguise.
Which brings us to this final thought. Putting a model into production isn't the finish line. It's the starting gun for a continuous race of monitoring, managing, and adapting. Because we live in a world of constantly changing data, the journey of your model is never, ever truly over. So the real question isn't just, is your model good now, but is it ready for what's next? Thanks for joining this explainer.